All right, review day 4. We are going to be combining like terms. To help us do that, we are going to identify terms and coefficients and then be able to combine like terms. A term is a number, a variable, or a product or quotient of numbers and variables. It's important that we remember what product and quotient mean. Product tells us it is what type of problem? Good, multiplication problem. And quotient tells us it is a division problem. So, for some examples, a term could be just a number. So somebody give me a number. 5. 5 is an example of a term. I'm going to separate my terms by commas. A variable is a term. What's a variable? X. We use X a lot. Or a product or quotient of numbers and variables. So we could have 5 times X, which we would just write as 5X. We could have 5 divided by X, which we would usually see used using a fraction bar. We can involve multiple numbers and variables at the same time. So like on our homework the other day, we saw something that looked like 9xyz. That whole thing is considered one term because we're just multiplying with all of it. You could also see terms that have exponents on them. Does anybody know what an exponent is? Good, a power. So it's a small number that's usually written a little bit above the variable. So 2x cubed is considered a term. All right, a coefficient is the number in front of the variable. So if we have a term, it's the number in front of the variable. So for example, if we were to use 5x, what would the coefficient be? I heard somebody say it. 5, the number in front of the variable. So on these examples, I'm going to circle the coefficient. When we had 9xyz, what was the coefficient? 9. When we had 2x cubed, what was the coefficient? 2. Okay. Let's switch it up a little bit. What about the coefficient for x? 1. Good. So remember there is a 1 that exists in front of that x. If you want to kind of draw it like with a dashed line because we don't always see it. 1 would be the coefficient on x. All right, on these examples, we are going to name the coefficient. I would write down those directions. Name coefficient. So when you look back, you know what we were doing. What's the coefficient on 1a? Jermila? 5. We kind of already did that one. I didn't know it was coming, but that's okay. 5 is the coefficient there. What about on letter B, Hunter?
-2.
-2. Good. Coefficients can be negative. What about on C? Janaya? 1. Good. That is like the 1x example that we saw. That would be 1 RS. Letter D is one that we have not really talked about yet. Does anybody think they know the coefficient there? Jordan?
Negative 1 over 4?
Very good. Negative 1 over 4 is considered the coefficient. Okay, because we could rewrite this as negative 1 over 4 times AB. That's the same thing. That makes negative 1 over 4 the coefficient. Terms are separated by addition or subtraction signs, or plus or minus signs. However you would like to write it. Addition, plus signs. Should make it straight up and down. Or subtraction signs. Multiplication and division signs do not separate terms. Okay, so when we're multiplying 9xyz all together, like we saw earlier, that's considered one big term. Only plus or minus signs can separate terms. How many terms do we have on letter A? I think there's more than 2. So one way I like to do this, if I'm not quite sure, is that I start underlining, but anytime I see a plus or minus sign, I don't underline it. So that means I start underlining, but then there's a plus sign, so I stop. I keep underlining, and then there's a subtraction sign, so I stop. I underline the last. So how many things did I underline? 3. That means there are 3 terms. Okay, now you are not required to use the underline method, but if you need to, or if you want to circle things, you can do that too. So how many terms do we think we have on letter B? Deshaun? 4. Good. We've got the negative 1/2 x, the 2/3 xy, 4/5 y, and a 3 on the end. 4 terms. So we are going to care a lot about like terms in this class. Again, something I think you've probably talked about before. It says that they vary in their coefficient. So in this sense, what does vary mean? What's another way we could say that? Their coefficients could be familiar with that word vary? This word vary means that they change. So that means that their coefficients could be different. That's another way of saying it. Coefficients could be different. Doesn't mean they have to be different. Most of the time they will be. But for like terms, variables and exponents are exactly the same. So they have to have the same exact variables, whether that's one or many, and those variables have to have the same exponents from one term to the other. Again, I would get the directions down. Are these like terms? Or you could just put like terms, question mark. That's what we're wondering about these. So our answer will either be a yes or a no. What do we think about 8m and 13m? Like terms? Yes, those are like terms. Their coefficients, or those numbers in front, are different. That's fine. But the variable m is exactly the same. So yes, those would be like terms. On letter B, 4x squared y and 5x squared y. Yes. So again, the number in front changed, but both of them had an x squared and both of them had a y. And that's it. So they do match. What about letter C? Why not?
Doesn't have the exponent on the 5.
Okay, so one of them has an exponent, the other one doesn't. So even though they both have an x, if they don't have matching exponents, they are not like terms. What do we think about letter D?
No.
Why not?
Because that's the same letters, but it's not like in the right order.
Good. So we've got m squared on the first one, but m is not squared on the second one. And then it flip-flops for the n. Okay, so even though they've got all the right pieces there, they're not put in the right place, which means no, they are not like terms. Anybody need more time on these? All right. Couple more examples for the same section. Letter E has like terms. Both of them are x squareds. The coefficients, again, are different, and that is okay. What do we think about letter F?
Yes.
Why?
Because the y, they both have two.
Okay, on both of them, even though it's written in a different order, the y has what exponent? The square, the 2. Y is squared. The y is squared on both of them, and the x is just a plain x. So even though they're written in a different order, we have to remember that multiplication is commutative. So if we wanted to, we could rearrange it on our own to make them be in the same order anyway. All right, on these we are asked to simplify. So before we start simplifying, here's something I want you to know. Okay, when we combine like terms, when combining like terms, we only combine the coefficients. Only combine coefficients. So what that means is that the variable and any exponents on the variables do not change. This is my and symbol, by the way, in case you see it and wonder why it looks funny. So now that we're a little more prepared to simplify these, when we see the directions of simplify for these, we really are just trying to combine like terms. So we first have to decide, are 21x and 10x like terms? Yes. If they're not like terms, there would be nothing for us to do. These are like terms. So we are going to simplify by only combining their coefficients. So 21 minus 10. 21 minus 10 gives me what? 11. The variable part doesn't change, meaning it keeps its x. Don't treat it like the x would disappear because it's x minus x. That's not what this says. Okay, it keeps its same variable part. On letter B, are they like terms? Yes. So what's actually getting added?
15 and 7.
Good. The 15 plus 7 gives me what? 22. X to the second power. Good. The exponent is not changing. Later in the year, we'll talk about when exponents will change, but this is not that situation. All right, more simplified problems. These are spaced a little bit weird, but they're not separate terms unless it's an addition sign between them. So when you write it, if you want to squish them together a little bit better, you can. It's just spaced out funny. On letter C, what terms there are alike? Liam?
9y2 and 13y2.
Good. 9y squared and 13y squared are like because they have matching variable parts. So that means we can combine them. So really we're just taking 9 plus 13. What does that give us? 22. The variable part does not change. What do you think has to also be part of my answer? The plus 3. So if there's nothing to combine with it, it still just drops down and becomes part of your answer. So this piece just had to move down and stay on the end there. Can I combine 22y squared with the 3?
No.
Why not? Okay, the 3 doesn't have a variable at all. They are not like terms. Letter D, what did we combine? Dominic?
Oh, 11, 8 to the second minus 11, 8 to the second plus 12, 8 to the second.
Wonderful. They all have a to the second, so they can all be combined. So that means that we are taking 11 minus 11 plus 12. Now we have to follow our order of operations, which means we are going to work from left to right. So don't go adding those together before you subtract. 11 minus 11 would give me 0. 0 plus 12 is 12. So we have 12a to the second because our exponent does not change. One helpful hint I'll give you before I stop talking for a minute is that if we wanted to put a number right in front of the x, but it would be a 1. So if you need to write in a 1 right there, to remember that's minus 1x, you can do that. On letter E, when we combine 3 plus, well, really it should be 3 plus a negative 1x or minus 1x. If it helps you to rewrite it below to see it, you can. You've got to make sure you keep the sign that's right in front of that term. So that's where this can get a little tricky. Okay, so that would give us 2x. The other piece of that would be to combine the plus 12 with the plus 5. So positive 12 plus 5 is where we got that positive 17. There we go. So that is our answer. The 2x and the 17 cannot be combined. Questions about that one, especially with the negative 1x or minus 1x? Okay, keep the sign in front of the term. All right, on letter F, what did we get? Annabelle?
5a plus 10b.
5A? I didn't get 5A. I do agree with the 10B part. Darius?
3A plus
3A
10B.
plus 10B. Good. So there's nothing to combine with the 10B. Hopefully we see that from the beginning. So we know we'll have a plus 10B. For the A's, how many A terms do we have? 3 of them. So we have to take 5A minus 7A, and then on the end there we've got a plus 5A. Okay, so if we're going in order from left to right, 5 minus 7 would give me what? -2, and then we add 5 to that, and we get 3. So that's where the 3A comes from. And of course the plus 10B just has to come down to our answer. Okay. Questions, concerns about where any of that came from? Anybody get them both right? Good job. If we didn't, do we understand what happened? I hope so. If not, please ask questions. On letter G, what can get combined? Everything?
Oh, yeah, I was.
Not everything, but which two?
9 and 10 x. I mean, 1 and 2 right.
I think I disagree a little bit. Jamila? Okay, so the x squareds can get combined. What number is sitting in front of this x squared? A 1. So if we need to rewrite it separately to do it, we can. 10x squared, we keep the sign right in front of the number. So that means this is going to be minus 1x squared. Janiyah, maybe you were already telling me the answer to this. When we combine these, what do we get?
X squared.
A 9x squared. But what else is part of my answer?
9y squared.
The 9y squared has to come down to be part of the answer. Anything that we don't combine with something doesn't just disappear. It's got to be brought down and put into our answer. Letter H, do we have like terms? Yes, they're both x's to the first power. So we are going to take a half plus a half. What do we get?
2, 4, 1.
1. If I give you half of a pizza and then I give you the other half of a pizza, how much pizza have I given you? 1 whole pizza. Okay, so when we're adding fractions, make sure you're not just adding the top and adding the bottom. Okay, 2/4 is the same as 1/2. And if you're adding 2 halves together, then you're not just still only having a half. Now you have a whole. So this is going to be 1x, or you could just write it as x. Are we all okay with a half plus a half being 1? Okay. If it helps, think about it as like money or a pizza or something. If you have 2 halves, you put them together, you end up with 1 whole 1. On letter I, do we have like terms? Yes. Now, I brings in an idea that we've sort of talked about when we talked about opposites. But if I were reading this whole problem, I would probably read it as negative 16m minus negative 38m. Some of you have already said this before, but if we're subtracting a negative, what does it really mean we're doing? adding a positive. So if you are one of those people that likes to turn it into one big plus sign, you can do that. Or if you like to rewrite the whole thing, that's also fine. The parentheses were only there to separate the two minus signs from each other. Okay, so now we're ready to combine. We're taking negative 16 plus 38. You're not great with your operations with integers. I would maybe have a scientific calculator handy to help me out. Does anybody know what we get? 22, good. 22m. Done. Ready for the next one. Letter J, do we have like terms? Yes, we sure do. So we can just take 18 minus 24. Make sure you're reading it left to right so that you get your signs right. All right, so what do we get when we take 18 minus 24? Negative 6p. Good. Make sure you're going from left to right. Make sure you're watching your operations with integers. And if you need help with that, I would invest in a scientific calculator. Get one from a sibling, a cousin, a friend. Ask for one for your birthday. I don't really care. It will help you out throughout all of your math classes in high school. That's it. All right.